G'day guys, today we've got a little bit of a tricky one. We're going to make our objects and our object management system. Now it's a bit tricky because we're going to have so many different objects in a game like this. You've got trees, you might have 10 different types of trees. You're going to have rocks, that's just the static items that will sit on the map. And for each one, there's going to be a different way that you will interact with it, that the characters will interact with it. They're going to have different properties. So a rock's going to have different properties to a tree. When you chop down a rock, you're not going to get wood. And you're not going to get rock when you chop down a tree. But we're also going to have weapons, and every weapon needs to have things like damage. It's going to have, how long it takes to swing it. It's going to have things like weight, heaps of different things. Then you can have food, and food's going to have nutrition and all these different things. And we don't want to have one item class which has to remember a million different things. So we're going to use inheritance. So what I'm going to do first, we're going to have to be quite organized because we expect to end up with just hundreds of objects in the end. So I'm going to create a new folder, and I'm just going to call it item. And then in item, let's create our base item. So we're just going to create a new scene, and it's going to be a sprite 2D. Because one thing that all of these guys are going to share is that they're going to just show a picture and have a position, and the sprite 2D will hold that for us. So let's go ahead and just call that item. Now I've made a little object tile set, just a few things that I drew up. Let me show you this. So I just quickly did this in an image editor. So you can see I've just made a tree, a wood, that ugly thing there, that's supposed to be the simple meal from Rimworld. I've made a little bush, a bush with berries, and a little pile of berries, a bed, which covers 2 tiles here, a melee weapon, a sword, and a bow. And what we're going to do to apply one of these, we're actually just going to use what's called an atlas texture. So click your item, which is a sprite 2D. Let's zoom in on where he'll be. Did I call him a node 2D? Bollocks. No, it's a sprite 2D. What? Here it says sprite 2D. Here it says node 2D. Let's try again. So, new scene. The type is going to be a sprite 2D. There we go. We're going to call him an item. And over here for our texture, we're going to grab an atlas texture. So atlas texture lets you grab like one giant texture and then just select a small part of it. And so we choose our atlas texture, our atlas. We're just going to quick load and grab our object tile set. You can download that from the description, by the way. And now we're going to set the size to 16 by 16. And you can see the first one there is a tree. And to select the other guys, we just change the X and Y position. So let's just make a piece of wood, the base picture. All right, now let's make now that's it, that's our little item. Let's add a script to it. Now let's think about what every item is going to have. So items don't necessarily sit by themselves. You'll often have piles of them. So let's have export. I do want to have all these show up on the right so I can quickly see them in the inspector. Var count, and that's going to be an integer. Let's give each one a weight. I'm imagining that as the weight per item, so it'll be a float. So some things might weigh 0.1, but if you're carrying 10 of them, and we may not implement weight in the end, but I'm just thinking, what are the things that every item will have? And I can come back and change this later. All right, that's all I can think of for now for the very base class. Now, this important thing we have to do, because we're going to extend this class. And when I say extend, you can see this script I'm writing now extends sprite 2D. And if you're familiar with that, that actually means that you can use all the different methods built into sprite 2D in this one here. And you can also see how it works if you look to the right. You can see we've got our node. Our node is the very base class. And then we've got a canvas item, which actually extends node. The node 2D extends the canvas item. The sprite 2D extends the node 2D. And then finally, our item extends the sprite 2D. We can use all the methods from node and the things that node has. We can use all the methods and variables that canvas item has. So what we're going to do now is we're going to extend our item class, and we have to call it a class first. Class name item. And now we can extend that. Or let's save this as an item. Make sure I saved it in the item folder. Is that one I made by mistake? Okay, so now we've got our base item. And what I'm going to do now is let's make food. So we're going to make another folder called food. There's a good reason I'm putting them in different folders. And let's for now just duplicate our item into our food directory. Rename that to, let's make our base one be berries. So this one is berries. Okay, so now I've got the berries, which is still a log. So let's just go and change that to be the berries. I'm just defaulting that to 3216. All right, now I'm actually going to remove the food script. So I'm going to remove the item script, and I'm going to add a new script, and we're going to call this one food. And it's going to extend the item script. Okay, so let's give this one the class name of food. And what I'm also going to add, so the food is going to need to know things like nutrition, like if the people eat it, how much of their food stat should be filled up by it. So we're going to add those, but rather than just saying like, var nutrition equals, say 1.0, and we can have that. But I also want to know if it's vegetarian or for carnivores or for omnivores. So if you can eat omnivore food, it has everything. If you can only eat vegetarian only food. And we could just give that a number 0, 1, and 2. But then I've got to remember the numbers. So what we're going to do is add what's called an enum. And so we just go enum, and it's going to be food type. And type 0 is going to be, let's see, this one's for omnivores. And we'll make a vegetarian one. Vegetarian is 1. And carnivore equals 2. We may have some more exotic styles in there later. And let's see, so Rimworld's you've got like berries and sort of rubbish foods like that. Then you've got simple meals and the more, I can't remember what complex meals, what are they called? And you've got like the really high level ones. So let's have that as well. And maybe that can affect the happiness or satisfaction, or maybe we'll have certain kind of like, stuck up people who only eat the better kind and get grumpy if they don't eat the good ones. So let's go food, I guess food quality. And we'll have rubbish, simple, good, and fancy. All right, let's make, so we've defined those. These are now like variable types. Like if you've got integer or string, we've now got food type and food quality. So now what we do is we just go export the variable, and let's call it food type. Notice I start with a small f, and its type will be food type. And we'll do one for food quality as well. Okay, so now I've got my berries, and let's give them a nutrition of 0.5. They're vegetarian food, and the food quality is rubbish. So that's my script for food. And what I can do now, let's go grab these berries. And what I'll do is I'll just duplicate that, and let's make one for the simple meal. And I just realized I've been giving these lowercase. I want to make that uppercase. All right, so the simple meal, we're going to go in here. Let's go in here and call it simple meal here. So it's going to have the same script. And let's check the picture. So it's got the picture of the berries. So let's go over, and you can see I've got food, which extends item, which extends sprite 2D, and I can get my texture in there. And I just scroll around. I think it was up here. That's right. So set the actual pixels. There's other ways you can find this. I think you can actually go and check the region. Yeah, if you get the region, you can actually find it directly. You can do things like grid snap. So if I set the grid to be 16, which is what it should be, you can see now I can just go, that's the one, or that's the one, or that's the one. You can even just tell it to do it automatically. So what am I doing? I'm doing that one. All right, and that's my simple meal. So save that. And so now we've got berries and simple meal, two different objects. Oh, sorry, for simple meal, let's set its nutrition to, what do we set the berries to? 0.5. Let's set the simple meal to 1. Omnivorous, because it's going to have, let's imagine it's got food. Sorry, let's imagine it's got meat and vegetables. And let's give it the simple quality. So people will be happier eating this one than the berries. And we save that. And so now in game, we can go ahead and we can drop in berries. And we can drop in our simple meals. And they come in with their script. So that's it. Now, for doing weapons, it would be exactly the same. I'm not sure if I'll do it now, but you would just in your script, make it go from item, make it extend from item, and you'd work out what kind of variables it needs. But let's do food first. So what I want to do now, I've got the basic kind of items and I can definitely extend that. I'm going to have to extend that. What I want to do now is make something as part of the game, which actually spawns these guys in for me. So what I'm going to do, and also we need some things like one of the characters wants some food. How does he find the food? So there's going to be a list of food, and in fact, a list of all the items. If he needs to cut a tree, we don't want to go searching through these whole sort of game trees. We're going to have one little script which handles it for us and holds all that information. So we're going to add a child node, and it's not going to be in the game. It's just going to hold a script for us. So let's grab a node, and let's call it our our item manager. And we'll give that a script of the same name. So the first thing this is going to do, it's going to keep an array of all the different kinds of, I'm not sure yet if I should have one list for everything or if I should have a list for all the food types. And then if I've got a list of everything, then if I want to check all the foods, I've got to sort the list. So I think for now, I might change it later, but let's just go var. Let's call it food, and I'm going to call it the prototypes. And the reason I want to call it prototypes is because these are not going to be things that the characters can access. I'm also going to have a list of actual food items. Well, let's actually call it items. Let's just items in world. So that'll be a list of all the items actually spawned into the world. But this one is a list of all the food prototypes, which we're just going to remember from here. So let's make a little script to load all the things in this folder, or list the berries and the simple meal into this array. So let's go load the food. So later on we'll have another one for loading the weapons. This is why I'm keeping them in different folders, by the way, so I can do this. And the path we need to know. So the path is res, and it is item and food. Item, food. Now to actually get the directory access to that, we go the directory, dir access, open, and we open that path. So now we've got directory access to there. Go dir.open. Then we need to go dir.list directory begin. And what we do now is we loop through the whole thing. Sorry, small t in Godot. And we're going to get the next file name. So that'll grab the next, it'll go berries, and then food, and then simple meal. And if the file name is nothing, we'll break. So that will break out of this while loop, because if we're getting an empty file name, that means we've hit the end of the list. Elif, file name ends with .tscn. So what I'm doing is I'm checking for only the tscn files, because I don't want to load the food scripts. I only want to load these scenes. And what we do is we go food prototypes, and we append, and we load the path, and then a /, and that file name. So that will give us that path with that file name and the little slash in the middle. Oops, and I spelled append wrong. So now that's added it to the list. What I'm going to do is for now, I'm just going to print it to make sure it's worked. So let's just print the file name so I can check to make sure this is actually working. And then finally, when we drop it out of our while loop, we go directory, list, the end. Oops, that should be a double equals. I see, I wrote dar instead of der. Okay, so let's see if this works. Let's just on ready. Let's run load food. So that'll print each file name. And then let's also at the end, print food prototypes and see if it's full. All right, let's run it. Okay. So yes, we've got berries.tscn, simplemeal.tscn. We haven't read the food one. And now our array has 2 packed scenes. So that's it, that's worked. So now what I'm going to do is put in a function, which will be accessed somewhere else. Maybe the terrain builder or something like this will spawn it in. So we're going to, let's not put it there, let's put it a little bit lower. Let's go func, spawn item. And we need to know the item. And we need to know the position. So and let's use it up here first. Let's go spawn item, and I want to spawn, let's just go food prototype, whoops, food prototype number 0, and let's spawn it at vector 2, just 10 for now, just something a little bit random. So I'm just seeing if it works. Oh, let's get rid of these prints as well. We don't need them anymore. All right, so the spawn item. First of all, we need to actually make the new item, spawn it in. So var new item, and we just go item.instantiate. Easy as that. So we're going food prototype number 0.instantiate. Prototypes. Okay, now they are going to have to be added to the list here. So I'm going to actually put them in as children of ItemManager, just so we can, all the items will be stored under here, so they're not going to fill up this list. So add child new item. And I'm going to add it to my items in the world list, so I've got easy access to it without going and finding the children of this. So items in world.append new item. Then finally, we're going to set the position of it. So item.position equals pos. All right. Let's give it a go. So we should have, first of all, let's go back and let's, I thought I already put some in. All right, let's press run and we should have 1 berries spawned in. Sorry, I said item.position. It should be new item.position. I was talking directly to the item prototype, not to the one I've just spawned. So let's try that again. And there we go. Now here's the tricky thing. That's at 10 pixels by 10 pixels. When I spawn things, I actually want to use my grid system. So this is going to be a bit confusing throughout because we've got these squares. And so I want the coordinate system of the map to be 0, 0, 1, 0, 2, 0. But the actual pixel position of this, that's 10 pixels by 10 pixels. So we've got to fix that. So let's define what we're actually doing. So what I want is the map position to go in here, not the world position. So the map position, let's make that be our grid positions, and the world position is always the pixel one. In fact, what I'll do is I'll actually make a little function called world to map position. Actually, it's the other way around. What the other way around I want first? So map to world position. And so we give it the map position X, which is going to be an integer. We give it the map position Y, which is going to be an integer. And this is going to return a vector 2. And we just return vector 2 map pos x multiplied by 16 and plus 8, and that puts us in the middle of the square. Map pos y times 16 plus 8. And so what happens now is I can hand this one the world position, sorry, the map position. I hand this one the map position, and then when I put it here, it's going to be translated to the world position for me. So now when I say I want it at 10, 10, that is the map position, which means it'll put it 10 across, 10 down. All right, so let's make sure that works, that it drops it at 10, 10. That looks right to me. All right, let's put in a few. So let's grab, so number 1 will be the simple meal, and let's just put them at different places. All right, let's give that a try. All right, so now I've got some food scattered around. And let's make sure it's all going into our prototype, all into our items in the world list. So print items in world. So there should be 1, 2, 3, 4 items in the world. And there we go, 1, 2, 3, 4 items in the world. So now we've got food items. So the final thing I want to do today is I want to make sure he can actually, my little guy here, he can find the nearest food. Because imagine he gets hungry. We could just pick the first food from the list, which could be any of these. It's going to be really annoying if you've got one that's all the way over this side and he ignores this one to walk over there. We could randomly pick one from the list. Same problem. What we need for him to do is search through the list to find the nearest one. Not too hard. So let's make another function we can call. Function find nearest item. Now here's the tricky thing. I don't want to find the nearest item. I want to find the nearest food. And I don't necessarily want to add a different function for each find. What I'm going to do is I'm going to put it in as a parameter. So the item category, and my categories, I haven't defined that yet, but that will be my base item, my food, could be a weapon, could be melee weapon. So there's actually going to be subtypes as well. So if I just say all items, it'll give me all items. So let's go up here and make a new enum called item category. And so item can be 0. Food can be 1. Weapon can be 2. And I'll also have subclasses of that. Melee weapon, 3. Let's say projectile weapon, 4. Now, I thought about this for a while. I wanted to be able to search through and just search by the actual class name. But as you can see, I've got here in berries, it's got this class name for food. I couldn't find a good way to do it, so maybe one of you guys can tell me. So what we're going to use instead is groups. Now, groups you can type in here and add different objects to group, but we're going to actually do it built into our objects. So let's go back to the base item first. Where's my base item? Did I lose it? Bloody hell. All right, let's put a new one back. So we'll just duplicate berries, put it back at item. Oh, that moved it. Oh no. Duplicate berries, make it called item, put it in the item folder, open it up, rename it all to item, get rid of the berries, get rid of the food script, and attach the item script. There we go. Now, what we're going to add is func init. So this one's called even before ready. And what we're going to do is just add this guy to the group, and the group is item. Simple enough. Sorry, not add group, add to group. So now he's added to the group, item. Now here's the tricky thing. We go to the next level up, which is our food. And this one, we add func init. Now we want this guy to be added to the group, food, but I also want him to be added to the earlier group. Now I could just say add to group item as well, but there's a better way. We just go super.init. And what that will do is that will call that init function in that level above in the item class. So it'll already be added to item. And it also works downwards as well. If I extended the food class and I had, I don't know, awesome food class, and then I had that added to the awesome food class, it calls its super method, which would be the food class, which then would of course call the super method again, which goes all the way back up to the original item class. That's inheritance. So this will be handy when we get really deep into the different types, when you've got an item which is extended by weapon, which is extended by melee weapon, and we may even have extensions there as well. So now what we do is back to our item manager. Now, because when I'm checking it, that group is actually a string, so we need to add one more thing. I'm just going to add a list of item categories. Whoops. Item categories. It's going to be a list, and so it's just going to be these. So when I say give me number 0, it's going to give me item. When I say give me number 1, it's going to give me food. When I say give me number 2, weapon, etc. So now what I can do is have a little comparison. So func is item in category. And so we just have the item and we have the item category. And this will of course return a Boolean. And the easy way for this is just return item is in group. And we go item categories. This is our list, and the element we're going to get is the item category. And of course, we could just put this line directly in wherever we are checking, but I think is item in category is easier to read. Well, let's before we go and do this, find nearest item, let's test is item in category. So let's just print is item in category. The item, let's give it food prototypes number 0. And is it in category item category dot food. And then secondly, let's see if it's in category dot item. And thirdly, let's see if it's in category weapon. So we should get true, true, false. I'm sorry, I've done the same thing again. This only works with spawned items. It won't work with these food prototypes. So let's instead grab from items in world. So once again, that first one should be a berries. So this should work. We should get true, true, false. True, true, false. Perfect. So that works. So now we can search through. And when I say, give me the nearest item of this category, I can tell it I only want food. I can tell it I only want to find the nearest weapon. And then of course we want to give it the world position so we know closest to where, which is a vector 2. So first of all, if there's no items in the item list, I just want to return false. So if the len of items in world equals 0, then we're just going to return false. And then we need to do a little algorithm. We need to do a little algorithm to find the nearest item. So it's going to search through every item in the list. And if it finds one closer than the most closest so far, it'll bump that up to the top. And of course, if it's not a food, it will ignore it completely. So we just go var the nearest item so far. We'll start that at null. And var nearest distance, and let's just make that 99999 something stupid. All right, so now we loop through all the items. for items in world. We go if is item in category, and the category has to be the item category we've passed in, and I have to give it the item as well. So if this item is in this category, then we're going to get the distance. The distance is going to equal the world position that we've passed it. And vector2s have this great thing called distance 2. And we're just going to check it compared to the item dot position. And if nearest item equals null, so if this is the first item we found in our list that suits our goals, we go, all right, that's the nearest item. Nearest item equals item. Not item categories, nearest item equals item. Nearest distance equals distance. And what we'll do then is we'll continue. So we'll skip the next bit and do the next element in the loop, if you're not familiar with continue. Now, otherwise, if the distance is less than the nearest distance, then we do pretty much the same thing, except we'll let it return again. So this will go through and it'll search everything, every single item, and every item that matches the category. If it's closer, it'll stick it in here for temporarily, and it'll keep going through until all of them are checked. It'll keep going through until all of them are checked, and with us having the nearest one. And finally, we return the nearest item. So that will give us the nearest item of a certain category from this position. And let's test that. Let's go to our pawn, our little guy. The pawn code. And what we're going to do is I want him to know the item manager. So let's just put a little test in here. What I'll say is, so right now we've got, this is for when we click, it'll find our current position, get the target position of the mouse, and ask for a path to there. So let's do that similar thing. Instead of click, let's make it UI accept, which is spacebar. And we don't need the target position. Well, let's do target position, but let's make it ItemManager dot. Oh, I forgot what I called it already. ItemManager find nearest item. Find nearest item, and we go ItemManager dot item categories dot food, and then we give our current position, which is just position. All right, and then we're just going to ask for that path. So from our current position to that target position. Yeah, so when I press spacebar, he should start walking towards the nearest food. Let's see if that works. All right, so there's my little guy. When I press spacebar, he should walk to here. Yeah, it said we had an error. Sorry, not food. Item categories was the list of strings. Let's go back and have a look. So I've asked for this one. What I actually want to do is get this list of categories. Yeah, that should do it. Let's try that. All right, once again, I'll press spacebar. So object 2, I'm sorry, I'm here taking the nearest object and putting it directly into there. I actually want to get the position of that object. Let's try one more time. All right, spacebar, and it's not working. Let's see if I'm actually getting that position. So print target position. Okay. Now I can tell you what the problem is. 200 is off the map, and the problem is the position I'm getting is the pixel position, and my pathfinding works off the map position. So what I need to do is convert that to the map position, and I know how to do that. I did the same thing with my own position. We just divide it by the rendering quadrant size, which is 16 pixels for each square. Let's try one more time. All right, press the spacebar, and there we go. He's walked to the nearest food. If I walk to here first, spacebar, he finds the nearest, he finds the nearest. So you see, whenever I press spacebar, he always finds the nearest food. So if he's sitting over here, doing some work, chopping down your trees, suddenly he gets hungry, bam, he'll walk over here, find the nearest food. Now in the end, we might make that more complicated. So there might be some sort of weighting where if he can get this crap food nearby, but there's a better one slightly further, we might, anything that is a crap food, you might add like a 10% tax onto it. So if you find this one is 10 meters away, you'll write that down as 11. But if this one is 10, you'll call it 10. Whereas if you've got a really high luxury one, he might divide that by 10. So you'll always try and get the better ones if they're available. But that's some tricks we're not going to do today. In fact, I think that's enough for now. I might go away and just flesh this out a little bit, add the weapons, add a few more items, even add some item types, some of the base type, which I think is what I'll leave. I'll probably make another one for plants, for trees. Anyway, I've taken enough of your time for today. I'll see you later.